Now let's understand the difference between compiled programming language and interpreted programming languages. Compiled languages have a private code. What does that actually mean? The difference is about how code is transferred before execution. So when we talk about compiled programming languages, examples like C, C++, Rust, Go, etc. In these kind of languages, the source code is first translated to a .exe file, which is an executable file, and then the full code is translated and compiled, and then it is run accordingly. Whereas in interpreted languages, the code is more in the public form, which means that the code has a more accessing authorities as compared to the compiled programming languages. Unlike compiled languages, in interpreted languages, the code is not translated into exe file. It is directly run whenever user want to have access to the source code. Here in compiled programming languages, they are not able to access the source code. Rather, they'll get machine level code because the file which is there is directly translated into the .exe file. So the user actually gets a compiled version of the source code and not the actual source code. Whereas in interpreted language, the user can directly have access to source code. That's why they say that the code in terms of interpreted language is public. Compiled languages are much more faster in execution as compared to interpreted languages. For a compiled programming language, it has to pass through many stages. First, we write the code, then we compile it, then the code gets converted into the .exe, which is an executable file, and then it is run finally. Whereas in interpreted language, we simply need to run the source code directly, and the code gets executed line by line. Hence, it gets slower. The CPU executes the machine code directly. There is no translation step during execution. The interpreter is involved at runtime. Code is optimized during compilation. The compiler can improve performance. Interpreter translates the code line by line at runtime. CPU executes through interpreter layer. The third difference is in terms of portability. Compiled languages are not portable, whereas interpreted languages are portable. Why is this so? In compiled languages, source code gets converted directly into machine code before execution, which makes it platform dependent. The compiler creates an executable file that is specific to a target operating system and processor architecture. That's why it lacks portability. An executable file created for a 64-bit Windows machine cannot be run on Linux ARM machine. To run on a different platform, the entire program must be recompiled for that specific architecture. Whereas in interpreted programming language, it is platform independent. The source code is portable. You can move the code to any system, be it Windows, Mac, or Linux, as long as the interpreter for that language is installed on that system. The next difference is users receive machine code. Users are having access to machine code in terms of compiled programming languages. They are not able to receive the source code, which makes compiled programming language very much secured. Whereas in interpreted languages, users directly have access to source code, which makes it less secure. Reverse engineering is difficult in terms of compiled languages. Compiled languages have a very restrictive nature, which makes it difficult to perform reverse engineering. Because if we perform reverse engineering on compiled languages, it may lead to loss of information, where variable names, comments, and structures might also get lost. Whereas in interpreted languages, it becomes quite easy to perform reverse engineering. Techniques like code reading, bytecode disassembly, runtime debugging, all of these are a part of reverse engineering, which makes it very easy in terms of interpreted languages to be performed. I hope this video was very informative for your academics, and if you really want such kind of informative videos, please subscribe to the channel.